The last section deals with distinguishable permutations and combinations. A distinguishable permutation is something that I can see all the different ways to write something. However, if I'm going to ask for arrangement of letters, for example, I can't designate the same letter as being two different things because to my eye, they're the same thing. So when I've got duplicates, I've got to divide out duplicates. So the example here is the word Mississippi. And Mississippi is 11 letters long. So N is going to be 11. Now I need to look at each of the different letters. M, I can see there's one M, so it'll be written as 1 factorial. I can see there's 4, which is going to be written as 4 factorial. S, there's 4 of them, which will be written as 4 factorial. And then P, there's 2 of them, which will be written as 2 factorial. Now, if I wanted all the possible combinations of Mississippi, it would just be 11 factorial. But since I've got these duplicate I's and S and P's, I can't tell the difference between those. So I need to divide them out. So I'm going to divide out the 1 factorial, 4 factorial, 4 factorial, and 2 factorial. I'm going to divide out those duplicates. Now I don't have to write the 1 factorial there. I just do that to emphasize that all the letters are represented down here. There's the little M, there's the letter I, letter S, and the letter P are all represented. So 11 factorial divided by 1 factorial, 4 factorial, 4 factorial, 2 factorial is 34,650. When order does not matter, we call it a combination, which means our choices are going to be less since they don't have to be in that specific order. So how many different ways can a committee of 3 be selected based off of a club of 40? Here I'm not saying president, vice president, treasurer. All I'm saying is what is the order that 3 people can be selected. So this would be 40, choose 3. And you can use the formula you see above, n factorial over r factorial, n minus r factorial. Or you can go to the math option on your calculator, go math probability, and then you'll see NCR there. The last example, how many subsets of a set of 4 elements can be formed? Well, first you have to know what a subset and what elements are. A subset of 4 elements would be something like A, B, C, D. There's your set of 4 elements. A subset then is any breakdown of that. So a subset of 1 element could be A, we could have B, we could have BD, we could have BC, and so forth. So a subset are all the different ways that I can break down the set of 4 elements. So we've got to look at what happens if we choose 0 elements, we choose 1 element, we choose 2 elements, we choose 3 elements, and then finally we choose 4 elements. If we have 0 elements, how many ways can I choose 0 elements? Well, that's pretty straightforward. There's only one way I can choose 0 elements, and that's by choosing no elements. So that's going to be, if I'm given 4 choices, I'm going to choose 0, which is 1. With 1 element, I can choose A, or I can choose B, or I can choose C, or I can choose D. That's pretty straightforward that there's going to be 4, which is going to be 4 choose 1. 4 elements possible, I'm choosing one of them. There's 4 different ways I can do that. If I'm going to choose 2 elements, that's AB, BC, CD, AD, AC, BC, and BD. That's 4 choose 2, which is 6. 3 elements would be ABC, BCD, ABD, CDA, all those different combinations of 3. So 4 choose 3, and there's going to be 4 different ways you can do that. And then finally 4 elements, 4 choose 4, which is 1. That's if I choose everything. So how many different subsets can I have? 1, 4, 6, 4, and 1. That means there are 16 subsets that I can have. Add all those results together. So to summarize, if order is important, you use a permutation. If I'm creating a subset of a larger set where the order is not important, you use a combination. And then finally, if you have separate events, you use the counting principle.